All right, we are going to find the first four terms of a sequence and a recursive rule, given that we are working with an arithmetic sequence and given the points f3 equals 10 and f7 equals 26. So let's find the first four terms. Now we have something going on here. We are given the third term, and we know this because it's x and this is y. We know that the third term is 10. So the third term is 10. And then what we're given is the seventh term, which really, if we look at it, we have 1, 2, 3, 4, 5, 6, 7. So we have all these other terms, and you'll notice that there's a big, gigantic gap in our information. So what we have to recognize is that when we're talking about an arithmetic sequence, we call that our common difference. And our common difference let us know what was happening between each of the terms. And as we discussed this, we said, well, our common difference was the same thing as our slope. And we know how to calculate slope. So let's not overthink this. Let's just go ahead and calculate that slope. So our first x was 3. And our first y was 10. So 3, 10 was our coordinate point. And then it gives us another one right here, which is 7 and 26 as our x and our y. So I'm going to write 7 and 26. Well, let's find our slope. So how do we change from 3 to 7? We say that's plus 4. From 10 to 26, that is positive 16. And what do? We do the change in the y over the change in our x's in order to find the slope or average rate of change. So we change in y, which is 16, over our change in x, which is 4, which means that our slope is 16 over 4, or just simply 4. All right, so what do we do with this? This is our slope, which is the same thing as our common difference, right? That tells us what to do between each one of the numbers. So if I want to fill out the rest of the numbers, I just need to add 4 or subtract 4, depending on the direction that we're going on. So let's go here. We are going to go this way. We would add 4 because our common difference is positive. So 10 plus 4 is 14. 14 plus 4 is going to be 18. Plus 4 again is 22. And plus 4 again would be 26. So that checks our work. But we wanted the first 4 terms. So let's go in the opposite direction now. So let's subtract 4. That brings us to 6. And then we subtract 4 again. And that brings us to positive 2. So what we can do now is we can write our recursive formula that models this data based off of our 2 points. So we'd say, okay, we were given the first term, a sub 1 equals to 2. And now we're going to write our arithmetic sequence or rule, which means we're going to be adding or subtracting. So I'm going to write a sub n. Remember that just simply means what we get next equals to the value of the term we have now. Okay, and what are we doing? We are adding 4 every single time. To get from 2 to get to that 6, we add 4. And then we add 4 to get to the next one and so forth. Okay, so there's our arithmetic recursive rule. Now I went ahead and threw on here, let's find our explicit formula. And we know that arithmetic is the same thing as linear. Okay, and linear is y equals to mx plus b. Well, guess what? We already have our slope. Our slope is 4, so let's plug that in. Y equals to 4x. And then we need b, which is our y-intercept. Well, guess what? We already know how to find our y-intercept. That is when we are in term 0, or x equals to 0. So we just need to go back one more step. So I'll do this in a different color so we can see it. Let's use orange. So I'm going to go back to term number 0. And I'm going to step back another 4 to get to term number 0. So 2 minus 4 is negative 2. So I'm just simply going to say, okay, well, there is our y-intercept. Okay, and I'm going to say 4x minus 2, because that is our y-intercept, and this is our explicit formula. So when we're given gaps in our data, remember we have to find our common difference, which identifies as our slope. Okay, and then we're going to use that in order to create our pattern, our recursive rule, and then we also use that to find our explicit formula. All right, I hope that helps you out converting from 2 points to a recursive rule.